Okay, we're gonna go with lesson 3.4 properties of logs. We start with the opening product rule. When we take the log of something that's being multiplied, we can split it into two logs of the same base, and multiplication will turn into addition. So if we had the log of base 5 of 21, you could turn that into the log of base 5 of 7 plus the log base 5 of 3, because 7 times 3 is 21. Or more often than not, maybe you've got the log base 2 of x, y, and now you can split it up into the log base 2 of x plus log base 2 of y. Both are options. Quotient rule, the quotient rule, division, the log, if you have the log of something that is being divided, division turns into subtraction. So you have multiplication is associated with addition, and division is associated with subtraction. So if you had, the log of base 8 of 9 over 11, you can turn that into the log base 8 of 9 minus the log base 8 of 11. So you've got division, and you can turn it into subtraction. You can also go back the other direction. You can take the log base 6 of x minus the log base 6 of z. You thought I was going to say y there, didn't you? And now you can say, okay, I've got the log of the same thing, and if I want to take her to one log, I can make it into x over z. So it works in both directions. Product rule and quotient rule. These will be used extensively when we start solving problems. Next, power rule is the best rule. Power rule is the best rule, and you can really see the power rule where it comes from when we're talking about, it's really repeated addition which turns into multiplication. It says here we can take this exponent c and we can swing it out front. So for example, if I have the log base 4 of x to the third, I will be allowed to swing the 3 out front and make it into 3 log base 4 of x. Now, if you paid attention to the product rule, which I'm sure a couple of you did, if you think about what it means to be x cubed, we could write that as the log base 4 of x times x times x. Product rule says the log of things with the same base will turn into addition. And here we go. We got 1, we got 2, we got 3, and that's where our 3 log base 4 of x's come from. So really the power rule is just the product rule in disguise. Swing this partner round and round. And this, my friends, is the ticket to solving for variable exponents. So now when we want to find out when will the population of Austin, Texas be 800,000 or whatever that might be, this is where you would take the log of both sides and solve. Wonderful stuff. Wonderful. Wonderful. Write an expression as a sum or difference of logarithms. Here we go. First one looks like a product, and it's a natural log. Oh no, natural log. All of these rules apply to natural logs. Multiplication turns into addition, and we're done. Next one. Multiplication turns into addition. Oh, we don't ever want to leave an exponent up here, so we can really go one step further and pull that 3 out front. Oh, we got cube roots, which are really to the power of 1/3. So would you follow me if I said this would be equal to, what would this be equal to? It would be equal to the log base 5 of x to the third over y to the third equals log base 5 of x to the third minus log base 5 of y to the third. And now I can swing those thirds out front. Heck, we could probably factor a third out if we really wanted to, but those thirds can come out front. So there's a variety of ways to get to this final answer, but either way we end up with 1/3 log x minus 1/3 log y. Down below, now we are going to put them together. We're going to put them together. Sometimes we want to take them apart, sometimes we want to put them together. I'm going to put these two together. I'm going to think to myself, that looks like a subtraction problem, which means we're going to apply the quotient rule. Now this only works for logs with the same base, so I'm going to have y over 3. And that, my friends, is how you go from 2 logs to 1 log. That's going to be very important. Oh, look at this next one. The first thing I'm probably going to need to do is reverse the power rule. I put the 1/5 up top, and now I can go ahead and log of 2 times x to the 5th, which really could probably be written as the log of 2/5 root of x. Either of those would probably be acceptable. The last one, got quite a bit going on here. First thing I'm going to do is I'm going to apply the ln of x cubed y all to the third. I can swing this back up and swing this back up plus ln yz squared squared. And now I can go to a single one, ln of, and really you could do this everything to the third, which would be x to the 9th y to the third times y squared z to the 4th, which ends up being ln x9 y5 z4. There you go. Change of base formula is very important. We can, this exploration, yeah, you can do that now if you wanted to. We'll do it when I get back. Change of base formula is very useful, most useful if you wanted to go to common logs or natural logs, which is what is on most calculators. Not everybody has the log base on a calculator, and that used to not be the case. So notice the base becomes what you're taking the log of there, and what you're taking the log of goes up and shows up there. So this 18 goes there, and the 7 goes there. Now, I'm not sure why you would want to change something to be a log base 3. The most useful thing to do would be to take the log base 7 of 18 and change it into log 18 over log 7, because you can now type this into your calculator just using the common log, the base 10 log. So that's where this is going to come up most often. Evaluate each using the change of base formula and show your work. Down here on the bottom, we can go log 16 over log 3. And now you can type that into your calculator. This guy here can go log 259 over log 12. Now they're both base 10. They're using the common log. Down here, natural log. You can change it. That's just a log of the base of e, isn't it? ln of x over ln of 3. That's it. I believe that's it for 3-4. Wow, that was simple and painless. My guess is they're going to ask you to do quite a few problems just like that for your homework. Hope you enjoyed this presentation and hope you have a wonderful today and a better tomorrow. Peace out.